Okay, I wanted to go through a quick example of how to use vectors and add vectors. So let's do this example about a hiker going on a walk. This hiker walks 6 kilometers, following a straight trail in a direction 30 degrees north of east. Then they follow another trail for 4 kilometers in a direction 45 degrees west of north. We've got two questions to answer. First of all, we want to know how far did the hiker end up from their starting point? In other words, what's their displacement? And the second question says, what direction would they have to walk to get back to their starting point? So in what direction would they have to go to reverse their displacement, undo their displacement? Take a moment to pause the video, see if you can work out the answer to these two questions yourself. Then unpause the video and come back. When you come back, I'll show you my solution. Okay. To start off, I knew I was going to need a coordinate system, so I've drawn myself a coordinate system. I've chosen focusing on just this first question, I've chosen an XY coordinate system where X is going to represent my eastward direction and Y is going to represent my northward direction. And so traveling 6 kilometers, 30 degrees north of east, I would have to go east first, and then I'm going to go at an angle north of east, 30 degrees, and then draw my arrow. And so there's my arrow. There's representing 6 kilometers at 30 degrees north of east. I've labeled this arrow L to represent the 6 kilometers and theta to represent the 30 degrees. And then for the next leg, I'm going 4 kilometers at 45 degrees west of north. So go north, then come 45 degrees west of north and draw an arrow. Of course, 4 kilometers should be less than 6 kilometers. So I drew a shorter arrow. This blue arrow represents my 4 kilometers at 45 degrees west of north. Okay. I labeled this D to represent the 4 kilometers and this symbol phi to represent the 45 degrees. My displacement, so the answer to my question visually would be this arrow, which I've labeled R, which is just going to be the sum of these two other arrows. So L plus D, but I can't do 6 kilometers plus 4 kilometers to get 10 kilometers. That doesn't work because they're not all in the same line. I've got to work out my components of my vectors, add up the components or subtract the components as appropriate to get the components of my result, and then put them back together to get how far I've gone, the magnitude of this displacement. So starting with L, I drew my L vector, my 6 kilometer vector, and I want to find the components. So how far did I go along that walk in the eastward direction, and how far did I go in the northward direction? Starting out with the northward direction, I can find the amount I went north by saying, well, my angle's here. This is the 30 degrees. This is the opposite side of my right triangle. Sine of theta would be opposite divided by hypotenuse. So if I do a little bit of algebra and I take the hypotenuse times the sine of my angle, I would get that opposite side. Sine of 30 degrees is 1/2. My hypotenuse is 6 kilometers long. 6 kilometers times 1/2 gives me 3 kilometers. Similarly, I can do the eastward component. That's the adjacent side of my right triangle. And so that's going to, the cosine of theta. So the cosine of 30 degrees would be this adjacent side divided by 6 kilometers. So if I take the cosine and multiply it by 6 kilometers, I'll get the adjacent side. Sure enough, cosine of 30 degrees is root 3 over 2 times 6 kilometers gives me 5.2 kilometers. So that's the northward. I went north 3 kilometers and eastward 5.2 kilometers during my 6 kilometer walk. Okay. All right, then I've got the 4 kilometer part. So that's going to be directed off in this direction, sort of upward and to the left in my picture, in my screen. That's going to, but I'm trying to find out my northward component and my westward component. Well, starting with my westward component, this time my westward component is the opposite side. And so I can take my hypotenuse, 4 kilometers, multiply it by the sine of my 45 degrees to get how far west I went. Sine of 45 degrees is root 2 over 2 times 4 kilometers, give me 2.83 kilometers. Then I can get my northward component by saying, well, that's the cosine of my angle. The cosine of 45 degrees is going to be this northward component times or divided by 4 kilometers. So if I take 4 kilometers and I multiply it by cosine of 45 degrees, I will get how far north I went. So 4 times root 2 over 2 again. Cosine of 45 is root 2 over 2, as we said. So 4 times root 2 over 2 kilometers is 2.83 kilometers. And that should make sense that both the westward component and the northward component are the same because my angle is 45 degrees. So I've worked out how far north I went during the first part and how far north I went during the second part, how far east I went during the first part, and how far west I went during the second part. So now I can put those together to find out the components of the result that I'm trying to find out. So looking at our overall picture, this is what we've got. We went in the east-west direction. We went east, 5.2 kilometers. Then we went west, 2.83 kilometers. So we're going to end up with a slightly east. I'm going to call that the x component of my result. Okay. In the northward direction, we went 3 kilometers north, and then we went another 2.83 kilometers. And so putting those together, I would get the northward component of my result. If I were to draw that result, then what I've got is I've got the eastward component. I went east and then I went west, so those should be subtracted from each other to get 2.37 kilometers overall. So 2.37 kilometers east. In the northward direction, both of them are pointing in the same direction, so they should just add 3 kilometers plus 2.83 kilometers, giving 5 kilometers, 5.83 kilometers northward. And then to find my overall displacement, the magnitude of my hypotenuse of this right triangle, I've got to use the Pythagorean theorem. Take the square of 2.37 kilometers, add it to the square of 5.83 kilometers, take the square root, and I got 6.29 kilometers overall. So this hiker, after going on these 2 trails, one of 6 kilometers and one of 4 kilometers, they end up 6.29 kilometers from where they started. But how do we answer the second question? Well, if we look at this, we could figure out the direction of our displacement. We know how far east we went overall. We know how far north we went overall. And so just looking at our right triangle here, we could figure out what this angle is. What's the direction of our displacement? You can do it in a lot of ways, but the simplest one is the tangent of this angle is going to be the opposite over the adjacent side. So that's going to be 5.83 kilometers divided by 2.37 kilometers. If I take the inverse tangent of this ratio, I can get my angle, which ends up being 67.89 degrees north of east. So if I go east and then come north, 67.89 degrees, that's the direction of my overall displacement. To get back home, though, I'd have to walk in this direction. I'd have to walk exactly the opposite direction of my displacement. Well, opposite the direction, that's the same angle, just instead of going north and east, I want to go south and west. So once I got the angle of my displacement, I just reverse the direction, and it's 67.89 degrees south of west. That's the direction I should go. So using vectors and vector components, vector addition, we were able to figure out not only how far the hiker was from where they started, what the magnitude of their displacement was, but also what direction they needed to travel in to get back to their starting point. Hopefully this example has given you some idea of how we can deal with vectors to answer a real-world problem. If you have any questions, please come talk to me.